Today we study the calculus 1. The topic is maxima and minima. Now look at the figure. Can you find the maximum value and minimum value? Maybe some point is our end point. Maybe some point are the points between A and B. And then you can ask you some questions. Does fx has some maximum or minimum value on the given closed interval S between A and B? If it does have a maximum or minimum value, why are they attended? If they exist, what are the maximum and minimum values? How to determine? So now we will tell you some idea to solving the questions. Now look at, let S is our the domain of the function f, contain the point C, we will say light. Fc is our maximum value of function f on the given domain S, under the condition if Fc is larger than or equal to Fx for all x in the domain. Pay attention to, it is our maximum value, larger than or equal to. And then Fc is our minimum value of function f on the given S, if Fc is less than or equal to Fx for all x in the given domain, minimum value. Together, if Fc is the extreme value of f on the given domain, if it is either the maximum value or the minimum value, this means both A and C. Maximum value and minimum value means extreme value. Extreme value. The function we want to maximize or minimize is our objective function, means objective function. So now we look at the theorem how to get the maxima and minima. Theorem A, maxima and minima exists theorem. If f is a continuous function on the given closed interval from A to B, we can get f will attain both a maximum value and a minimum value there. Means we can get maximum value and minimum value. So now look at the definition. If f prime c equals 0, we can give a new definition for the special point C. C is a stationary point, means stationary point. Look at definition 2. If f prime c fails to exist, this means does not exist. At this time, give a C a new name. C is a singular point, means a special case. So it is our singular point. The following three kinds of points, end points, stationary points, and singular points, are our critical points. If you ask me, what are our critical points? Okay, you should consider the three kinds of points, end points, stationary points, and singular points. Remember the definitions. Now look at the following theorem B, critical point theorem. Fc is an extreme value. At this time, C must be a critical point. You remember what is our critical point? Yes, there are three cases, means three kinds of points. So C may be an endpoint of the domain. F prime C equals 0 means maybe C is a stationary point. Maybe case 3, F prime C does not exist, means singular point. So we have the theorem B. Fc is an extreme value at this time. C must be one kind of critical point, endpoint, stationary point, or singular point. So now look at how to get the maximum and the minimum. Try to remember. Step 1. Find f prime x equals 0 or f prime x does not exist. What is our goal? Okay, try to get corresponding critical points. From the given domain, we will know the endpoint. From f prime x equals 0, we can get the corresponding stationary point. F prime x does not exist. At this time, we can get the singular points. And then evaluate f at the critical point. Evaluate the values. The last step, compare. Compare the values to find the maximum and the minimum. Try to remember. So now look at example 1. Try to find the critical point of fx equals minus 2x cubed plus 3x squared on the given domain. What is our critical point? Do you remember the definition? Yes, there are 3 kinds of points, endpoints. So, and then stationary points and singular points. So now look at the following idea. F prime x equals minus 2 times 3 equals minus 6x squared plus 6x equals 0. We can get, if f prime equals 0, get the 2 solutions. X equals 0 or x equals 1. It is our stationary point, no singular point. And then consider the end point. There are 2. One is minus half, the other is 2. So together, the critical points are minus half and 2 and 0 and 1. We have get it, the critical point. Now look at example 2. Try to find maximum and minimum values of the given function fx equals x cubed on the given domain minus 2 to 2. How to get it? Do you remember the 4 steps? Yes, I remember. Step 1, try to get corresponding f prime x. What is our f prime x? Yes, f is given x cubed. So corresponding the first derivative equals 3x squared equals 0. F prime x equals 0. There is only one solution. X equals 0. It is our stationary point. Step 2, count the number of critical points. What is our critical point? Yes, consider endpoints. Minus 2, 2. And the stationary point together, there are 3 points. Minus 2, 0, and 2. Step 3, evaluate the values of the function at the different critical points. f0 together, f0 equals 0. f2 equals 2 cubed means 8. f minus 2 equals minus 2 cubed means minus 8. The last step, do you remember? Yes, compare the values. We can find 8 is our maximum value. Minus 8 is our minimum value. So together, f maximum value is 8. Get it at the point 2. Minimum value is minus 8. We can get it at the point minus 2. So now the question is okay. We will look at example 3. Try to find the maximum and the minimum values of the given expression. Now, it is maybe complex, but the domain is the same, the closed domain, from minus 2 to 2, the same idea. So now we'll give the idea. If you know how to draw the figure, it is okay. We don't know how to draw the figure, how to do according to our computation steps. Now look at how to compute. Yes, get f prime x. we can get f prime x, the first derivative for our function x 2 over 3 equals 2 over 3 x. 2 over 3 minus 1 equals minus 1 over 3. And then minus 1 by 3 bracket x squared minus 1 minus 2 over 3 times u prime y. Change rule, yes. Change rule by the derivative. Time u prime means double x. How to get I prime equals 0 or doesn't exist? Taking out the common factor. What is our common factor? Pay attention to x power is 1. This x power minus 1 over 3, which is small. Yes, minus 1 by 3. So taking out together this term corresponding minus 2 over 3. No, this term means the power is 0. Together minus 2 over 3. It is our common factor. It is an equation. We can get another term. And now it is our expression. Write it in this form. Pay attention to this and this term become the denominator. And this is our numerator. What get it? Yes, critical point. How to get it? From numerator equals 0, we can get our stationary point. The denominator equals 0, we can get some singular point. So we can get singular points. X equals 0, all x equals positive or minus 1. Stationary points, we can get x equals positive or minus 1 over square root 2. And then endpoints, it's very easy. We can find it. Positive or minus 2. Together, 1, 2, 3, 4, 5, 6, 7. How many critical points? Yes, 7 points. Do you remember step 3? Yes, evaluate the values. 7 points may be 7 values, but you should pay attention to the fact f(x) is an even function, so we only consider 4 values is okay because it is an even function. So f0 equals 1, f positive or minus, they have the same values, so we only need to compute 1 value is okay. And then f1 equals 1, f2 we can get it. So now the last step, compare the values at different critical points. Compare each other. This is our maximum values. This is our minimum values. So we have our final result. F corresponding maximum value and minimum are getted. So now we look at the figure. Compared, yes, corresponding maximum value get it at the 2 points, okay? So positive 1 over square root 2 or minus 1 over square root 2. And then minimum values are get it. What point? Yes, at the end point. Maybe positive 2, maybe minus 2. Why? It's an even function, symmetrical. So at positive 2 or minus 2, we get the minimum value. So try to understand the question using the property even function and symmetrical properties. So now we look at the summary. How to get the maximum and minimum value. Step 1, get f prime x. Find equals 0 and does not exist the corresponding solutions. Step 2, together consider the critical points, including endpoints, stationary points, and singular points. Step 3, evaluate corresponding to values at each of these critical points. Last step, compare the values and then find the maximum and minimum. Try to use the 4 steps. So now, using the 4 steps, we will finish our quizzes. remember, the smallest of these values is the minimum value, corresponding the largest of these values is our maximum value. Using the 4 steps, we will solve some questions. Now look at question 1. Try to find the maximum and the minimum values of the function fx. Fx equals x 2 over 3 on the given closed interval from -1 to 2. How to do? Yes, according to our summary. The first step, try to find f prime x. This question is very easy. F prime is our x lambda form. So corresponding the first derivative equals 2 over 3 times x. The power is minus 1 over 3. So f prime x equals 0. We can find f prime 0 does not exist. No stationary point. So f prime 0 does not exist. This means 0 is our critical point. And then count the number of critical points. How many? 0 is our corresponding the critical point. Consider the end points. So together 0, -1 and 2. 1, 2, 3. There are 3 points. And then evaluate function values. F at the given point -1 equals 1. F0 equals 0. F2 equals the third root of 4. Compare corresponding which one is biggest, which one is smallest. We found 0 is our minimum, and this number is our maximum. In the similar way, we can do the question 2. Try to find the maximum and the minimum values of fx equals -2x cubed plus 3x squared on the given closed interval. Yes, using the 4 steps. Step 1, try to find f prime x. What is our f prime? Yes, -2 times 3x squared equals -6x squared plus 6x equals 0. F prime equals 0. We can find 2 points. Means there are 2 solutions. One is x equals 0. The other is x equals 1. Corresponding the stationary points, 2 points. Count the number of critical points. Critical points 0, 1, and then end points -half and 2. 1, 2, 3, 4. Together 4 points. Evaluate corresponding the function values. F at the given point -half, the value is 1. The 0 point, the value is 0. F value at the given point 1 is 1. Value at the point 2 is -2. Compare the values. We can find x maximum value is 1. Minimum value is -4. So try to remember the 4 steps. The class is over. See you next time.